Harshigowda. Harshigowda. Okay. Janvi.
Present, sir.
Right. Roll number 7. 7. 8. 9. Roll number 9. 10. 11. 12. 13. 14. 14. 15.
Present, sir.
Okay. 16. Roll number 16. 17. 18. 19.
Present, sir.
Okay. 20. Roll number 20. 21.
Present, sir.
Right. 22. 23. 24. 25.
Present, sir.
Okay. 26. 27. 28.
Present, sir.
Right. 29. 30. 30. Roll number 30. Suraya Bano. Okay. 31. 31. 32. Suraya Bano is present. Suraya Bano. Suraya Bano Kurundwad. Okay. 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 Right. Right. Tejas. Tejas. Vivek. Yamunappa. Gaokar Rajat Ramchandra. Roll number 35. Manjunath.
Present, sir.
Pratmesh. Joslino. Soham. Atiya. Atiya.
Yes, sir.
Okay. Anybody else?
Sir, excuse me, sir.
Yes. Tell me.
Sir, 5 present.
Roll number?
Sir, roll number 5 present, sir.
5. I have marked. yours.
5.
I have marked. Anybody else?
Okay, sir.
Right. Okay. Mute your cell phones. Mute your cell phone. Mute ಮಾಡ್ಕೊಡ್ರಿ. Manjunath, mute your cell phone. Manjunath,
Present, sir.
mute your cell
Sir, roll
phone.
number 6. Present, sir.
I have marked Janvi. I have marked yours. Okay.
Sir, roll number.
Marked. I have marked Janvi. Roll number 6. I have marked. Let us continue with the cascaded system. Last time I was explaining the two-port system. Right? Let us solve numericals on two-port system and Darlington connection. Take this numerical. For the below configuration, are you able to see the screen? Screen is visible. Screen is visible. Okay.
Yes,
Note
sir.
down this example. For the below configuration, determine.
Yes,
Okay,
sir,
fine.
visible.
Note down the example. For the below configuration, determine first one, the loaded gain for each stage. Second, the total gain for the system AV and AVS. That is AV, the total gain, and AVS is with the source resistance. The gain with the source resistance AVS. Then total current gain for the system. And fourth one, the total gain for the system if the emitter follower configuration is removed. For the below configuration, determine first one, loaded gain for each stage. Second, total gain for the system, AV and AVS. Third, total current gain for the system. Fourth, total gain for the system if the emitter follower configuration were removed. Note down this. Did you all note down? Have you noted down, students? Did you all note down? Ankita, is it noted down? Right.
Yes,
Now just note down this block diagram for the first numerical. This is a cascaded system where there are two stages. First stage is emitter follower. They are given the parameters of emitter follower, that is Zi input impedance 10 kilo ohm, Z0 output impedance 12 ohm. No load voltage gain is approximately 1. And for common base, input impedance is 26 ohm, output impedance is 5.1 kilo ohm, AVNL no load voltage gain is 240. And source resistance is 1 kilo ohm, load resistance is 8.2 kilo ohm. Note down this block diagram for the first numerical. Here there is a source voltage Vs, current flowing is II. Then here after the source resistance the current is II1 with input impedance Zi is equal to Zi1 and voltage across the input terminals is Vi1. Voltage at the output of first stage, it is V01. Input at the second stage is Vi2. Z01 is the impedance output at the first stage. Zi2 is the input impedance at the second stage. Then Z02 is the output impedance at the second stage. Voltage output at the second stage is V02. The total output voltage, final output voltage is V0. The final output current is I0. We can see here V01 is equal to Vi2. That is output voltage of first stage will be the input voltage to the second stage. V01 is equal to Vi2. Did you all note down, students? Is it taken? Chandrasekhar, did you note down? Harshgowda, noted down?
Yes, sir.
Fine. Okay. Now what they have asked, let us. Okay,
Yes,
fine.
sir.
Let us read the problem. For the below configuration, determine first one loaded gain for each stage. That means we have to find the gain of each stage with the load, considering the load. Gain of first stage, that is gain of emitter follower. Gain of common base amplifier. Then And second part is total gain for the system. We have to find the total gain. We know the total gain of the cascaded amplifier. The total gain of the cascaded stages or cascaded amplifier is the product of the gain of the individual stages. Product of the gain of the individual stages. Then they have asked the AVS, that is with source resistance, what will be the gain of the system. Then total current gain for the system, total current gain. Next is total gain for the system if emitter follower is removed. If emitter follower, this portion of the circuit, if it is removed, if this emitter follower circuit is removed, then what will be the, if emitter follower circuit is removed, this portion is removed, then what will be the gain of the system. These four we have to calculate. Let us start solving. Now for the first part, for the emitter follower configuration, the loaded gain is given by the formula. This is the formula. Now how we are getting this formula is, so this is the formula that we have used in the derivation of the two-port system, right? Now there we have used the formula AVL is equal to V naught by Vi, that is RL by RL plus R naught into AVNL. Let us go back to that equation. It is this equation. We can see here equation 6. AVL is equal to V naught by Vi, that is RL divided by RL plus R naught into AVNL. Just note down this equation. AVL is equal to V naught by Vi, that is equal to RL by RL plus R naught into AVNL. Equation 6. Note down this equation. AVL is equal to V naught by Vi, that is RL by RL plus R naught into AVNL. Did you note down this equation? Last time you already noted down, just I can refer to that. Is it taken?
Yes, sir.
Okay. Now here we have to substitute what is RL for the first stage, what is R0 for the first stage, what is AVNL for the first stage. Okay. This is the basic equation, right? AVL is equal to V0 by Vi, that is this equation. Now RL, what is RL here, students, for the first stage? Let us see the circuit, the diagram, what is given. This is an examination problem that is asked in the last time examination. This example I have taken from there. Now here the RL which you have noted down, that is nothing but for the first stage. Now we are finding for the emitter follower circuit. Okay, we are finding for the emitter follower circuit. We are finding for the emitter follower circuit, right, for this portion. Okay. Now RL for this portion is what? RL for emitter follower, it is Vi2. RL is, that is Zi2. Okay. That is input impedance of the common base that acts as the load for the emitter follower. Okay. So RL will be nothing but Zi2. The input impedance of the common base amplifier acts as the load for the emitter follower circuit. Therefore, RL will be equal to, note down, RL will be equal to Zi2. RL will be equal to Zi2. Okay. Next, what about R0? R0, R0 is nothing but Z01. That is the output impedance of the emitter follower. That is nothing but R0, output resistance or the output impedance. Right? Note down, R0 is equal to Z01. R0 is equal to Z01. RL is equal to RL is equal to RL is equal to Zi2, Zi2, right? And then R0 is equal to Z01, Z01. Okay, let's note down these two. Then accordingly, how to substitute. Then what is V0? V0 is nothing but the output voltage of the stage. It is emitter follower. So V0 is nothing but V01. V01. Is it not? Then what about VI? VI, VI is VI1 for the first stage, emitter follower. VI is VI1, VI1. Okay. Just note down these four. Then accordingly, we have to substitute in the formula AVL is equal to V naught upon VI, that is RL by RL plus R naught into AVNL. In that formula, just substitute this. Wherever there is RL, substitute as Zi2. Wherever there is R naught, substitute as Z01. Wherever it is V naught, substitute as V01. Wherever it is VI, substitute as VI1. Okay. So what will be the formula then? V naught AVL is equal to V naught 1 by VI1. That is equal to Zi2 into AVNL divided by Zi2 plus Z01. Correct? Whatever
Excuse
formula I
me,
have
sir.
noted. Yes, please.
So please admit Sanket.
Okay. Okay. Fine. See here. Now, whatever we have noted down here, just substitute in the formula that you have noted down. That is AVL is equal to RL by RL plus R naught into AVNL. What we get there? V naught 1 is equal to, if we substitute there, then we get this one. Just note down this. So we get V naught 1 is equal to Zi2 by Zi2 plus Z01 into AVNL into VI1. Correct? Because V naught is equal to V naught 1, RL is equal to Zi2, right? And R naught is equal to Z01. VI is equal to VI1. Then this is AVNL, no load voltage gain. So V naught 1 is equal to Zi2 divided by Zi2 plus Z01 into AVNL into VI1. Okay. Now we know Zi2, Z01, AVNL. Let's go back to the block diagram. What is Zi2? It is 26 ohms. That is, Zi2 is input impedance of common base, second stage, Zi2. It is 26 ohms. So substitute here 26 ohms divided by 26 ohm plus Z01. Z01 is the output impedance of the first stage. Output impedance of the first stage out of the, it is a output impedance of the emitter follower. That is 12 ohms. 12 ohms. Okay. So it is 26 ohm divided by 26 ohm plus 12 ohm. Then AVNL we are finding for the emitter follower, first stage. AVNL of emitter follower is 1 approximately. Substitute that AVNL is 1 into VI1 into VI1. Now simplify this part, students. 26 divided by 26 plus 12. Tell me how much you are getting. 26 divided by 26 plus 12. That is 26 divided by 38 is how much? 26 divided by 38. Calculate in your calci. 26 divided by 38.
Point.
Yes? Point?
0.6842.
1 minute, let us check. Correct. 0.6842. Approximately 0.684. That into VI1. Okay. Because what you have taken here for V01, we have rearranged the terms. Right. Therefore, V01 will be equal to this portion into VI1. That is 0.684 into VI1. Is it not? V01 is equal to 0.684 into VI1. Now what we want here, we want the gain of the first stage, that is emitter follower. Gain of the first stage will be output by input, that is V01 by VI1. That is AV1 is equal to 0.684. V01, rearrange the terms. V01 divided by VI1, take it to the LHS, it will come to the denominator. Therefore, V01 by VI1 will be 0.684, which is the gain of the emitter follower configuration. Okay, hope you followed this part. Next, we have to find for the common base configuration. Next one, we have to find for the common base configuration. Now, for the common base configuration, let's go back to the diagram. Common base configuration. Again, the formula is V02 is equal to RL divided by RL plus R0 into AVNL. Correct? V02 is equal to RL divided by RL plus R0 into AVNL into VI2. Correct? The same formula that you have used in the previous calculation. Same formula. Here Vi is Vi2, V0 is V02. that is equal to V02 is equal to RL by RL plus R naught, RL plus R naught into AVNL into VI2. Now what will be RL? What will be RL for the second stage? Just see the diagram. What will be the RL for the second stage? It is RL only, correct? It is RL only. Then RL plus R naught. What will be R naught for the second stage? It is Z naught 2. That is output impedance of the second stage. Okay. Let me write it. So for the second stage, for the common base amplifier, RL will be RL only. That is, they are given it as 8.2 kilo ohms. Okay. Then R naught 2, R naught 2, that is equal to output impedance of the second stage, that is of the common base amplifier, Z naught 2. Okay. Then what about the no load voltage gain? That is given in the diagram itself. RL is equal to 8.2K, that is RL itself. R naught 2 will be Z naught 2. Z naught 2 will be the R naught 2. Now substitute here in this formula. The formula is V naught 2 is equal to RL by RL plus R naught into AVNL into VI2. RL is 8.2K. You can just see here. It is 8.2K RL value. That divided by 8.2K plus R naught. R naught is Z naught 2. Z naught 2. Right? Output impedance of the common base, second stage. That is 5.1 kilo. It is 5.1 kilo into AVNL, no load voltage gain of the common base, 240. It is given. Correct? Into 240 into VI2. Into VI2. That is V02 is equal to 8.2K into 240 into VI2. That divided by 8.2K plus 5.1 kilo ohm. Now simplify this and tell me how much you are getting this portion. 8.2 kilo ohm into 240 divided by 8.2 kilo ohm plus 5.1 kilo ohm. Tell me that how much you are getting.
So that is 0.61.
0.61 you are getting. Just check. It is 8.2
Sir,
kilo
only
ohm.
that.
No, that into multiplication with 240. Multiply that with 240. Tell me the total value. Whatever that numerical is there, values is there. Just simplify those values and tell me in terms of V02 and
Sir,
VI2.
that is 147.96.
Very good. V02 is equal to 147.96 VI2. Correct. It is right. That is V02 is equal to 147.97 approximately into VI2. V02 will be this much. Now what we want? We want the gain of the second stage. Correct. That is V02 by VI2. V02 by VI2, that will be equal to 147.97. 147.97. Rearrange the terms. Therefore, AB2 is equal to V02 by VI2. That comes out to 147.97. Okay. This is part A of the numerical. Next, coming to the part B. Now, what they have asked in part B, the total gain, that is AV total and AVS, that is with source resistance, what is the voltage gain and the total voltage gain of the system. We know that the total voltage gain of the cascaded system, that is the system which consists of many stages, right? Its total voltage is given by the product of the gain of the individual stages. AV total is AV1 into AV2. There are only two stages here. One is emitter follower, first stage, second stage is common base, right? Therefore, as there are two stages, the total gain of the system will be the gain of the emitter follower multiplied by the gain of the common base. That is AV total is equal to AV1 into AV2. Whatever values you have calculated for AV1 and AV2, multiply them and tell me how much value you are getting for AV total. AV total will be AV1 into AV2. Tell me how much you are getting. AV total voltage gain.
Sir, it's 101.21, sir.
How much? 101.20. Excellent. AV total will be 101.20. Right. It is AV total 101.20. Fine. Next, they have asked the calculation of AVS. AVS, that is with the source resistance, how much is the gain of the system? Okay. Now this AVS is equation is Ri divided by Ri plus Rs into AVNL. Let us go back to that equation in the two-port system. It is this equation. AVS is equal to V naught by Vs, that is Ri by Ri plus Rs into AVNL. This equation. Okay. AVS is equal to Ri by Ri plus Rs into AVNL. Now here, before using this equation, here we know the for the two-port system, there are this we are considered only for one stage. Two-port system, these derivations we have done for one stage. Now, if we want for two stage, then this equation will be modified like this. Here, V naught will be AV total into VI. AV total into VI. And this AVNL will become AV total because it's the total gain of the entire system. Two-stage system here, what they have given in the example, numerical. That is, V naught will be AV total into VI, or V naught is equal to AV total into VI is RIVS divided by RI plus RS. VI is RIVS divided by RI plus RS. Just substitute this for VI. Therefore, we get AVS is equal to V naught by VS. That is RI by RI plus RS into AV total. Right? How the equation will be modified? Once again, I'll explain. V naught will be equal to AV total into VI because it's for two stage. We are calculating for the two stage. This equation we are done for only one stage. Therefore, V naught will be AV total into VI, or V naught will be AV total into VI is RIVS divided by RI plus RS. Substitute that and rearrange the terms. V naught by Vs, that is AVS, that will be equal to Ri divided by Ri plus Rs into this will be AV total. Instead of AVNL, we have AV total. That's the only change for two-stage system. Okay. So note down this equation, students. AVS is equal to V naught by Vs. That is equal to Ri divided by Ri plus Rs into AV total, AVT. AVS is equal to V naught by Vs. That is equal to Ri by Ri plus Rs into AVT. A superscript, say a subscript VT. Okay. AVT. Did you all note down, students? I hope everybody noted down this equation, the modified equation. Okay. Now we have to find what are Ri, Rs. Right. Now Ri for this will be the input resistance. Right. It is the input resistance. So input resistance of the entire two stage. It is nothing but Zi1. Correct. We are finding for the two stage. Right. The input resistance is nothing but Zi1. Zi1. Here you can see here. Ri is nothing but Zi1. This portion Zi1 input impedance, that is nothing but our Ri. Rs is different. It is a source resistance. Okay. If you want the input resistance, that is nothing but the input impedance Zi here for this emitter follower stage. So you have to take Ri is equal to Zi1. Note down this. Ri is equal to Ri, input resistance is Zi1, Zi1. Okay. Then what about Rs? Rs is Rs only. It's a source resistance, right? Rs remains as Rs only. How much is Rs they have given? Let's see in the diagram. Rs is 1 kilo. Source resistance. It is 1 kilo. Rs is 1K. Okay. Then how much is Zi1? Just see in the diagram. Zi1 is 10 kilo. Input impedance of emitter follower. First stage Zi1. It is 10 kilo. Okay. It is 10K. We came to know what is Zi1. Correct. Ri. Then we came to know Rs. And AV total. AV total we have calculated, correct? 101.20. Just in the previous calculation, we have calculated. Then find AVS. AVS is equal to ZI1 divided by ZI plus ZI1 plus RS into AV total. I have written the formula here. AVS is equal to ZI1 divided by ZI1 plus RS into AV total, or AVS is equal to ZI1 into AV total divided by ZI1 plus RS. Okay, that is nothing but ZI1 is 10K, that is our RI, then that into 101.20, this we have calculated, that divided by ZI1 is 10K plus RS is 1K. Answer will be 92. Just verify your answers. It comes out to 92. Are you getting this answer, students? 92 for AVS. Are you getting here? 92?
Yes, sir.
Okay, fine. Next part. So B part is completed. Next, we'll move on to C part of the numerical. The total current gain for the system. Total current gain for the system. Now, the formula for total current gain is AIT. Total current gain is minus AVT into ZI1 by RL. Okay. Here, this equation we are getting from the derivation that we have already done for the two-port system. This equation 7, AIL is equal to minus AVL into RI by RL. This is the current gain equation, right? That is minus AVL into RI by RL. This is for one stage. Now we are calculating for two stage. Therefore, this will be total current gain AIT. That will be equal to AVL. This will be nothing but AV total, right? For the total gain of the system minus AV total voltage gain of the system into RI. RI will be the first stage input resistance, that is ZI, that divided by RL. Okay. Now, how will be the terms here? Now, in this equation, note down this equation first. AIL is equal to minus AVL into RI by RL. This equation 7. Note down this. AIL is equal to minus AVL into RI by RL. Okay. Then, what is AIL here? AIL will become AI total. AIL will become AI total. AIL will be AI total, AIT. Then AVL will become AVL. This will become AV total, AV total, AV total. Next, what about RI? RI will be ZI1. Input resistance of the entire stage will be input resistance of the first stage. It is ZI1, ZI1. RI will be ZI1. Okay. Then RL remains as RL only. Load resistance is the same. Load resistance of the entire stage amplifier, it is the same. RL remains the same. Okay. So the equation accordingly modify the equation. The equation will be this. AIT will be equal to minus AVT into ZI1 by RL. Wherever there is AIL, put it as AIT. Wherever there is AVL, make it as AVT. Then wherever there is RI, that is ZI1, and RL remains the same. Okay. Now AVT, total voltage gain, we have calculated 101.20. This into ZI1. ZI1 is how much? ZI1, it is first stage input impedance 10 kilo ohm. ZI is equal to 10 kilo ohm. Substitute that to 10 kilo ohm. That divided by RL, load resistance. How much load resistance they have mentioned? 8.2 kilo ohm. RL, 8.2 kilo ohms. Okay. That divided by 8.2 kilo ohms. Now simplify this and tell me the answer, students. minus of 101.20 into 10 kilo ohm divided by 8.2 kilo ohm. Tell me the answer. Minus of 101.20 into 10 kilo ohm, that divided by 8.2 kilo ohm.
Minus 123.414.
Correct. Minus 123.414. It comes out to minus 123.414. Okay. Then last part of the problem. The total gain for the system if the emitter follower configuration was removed. If emitter follower configuration is removed, then what will be the total gain of the system? Suppose say we are removing this. Okay, we are removing this emitter follower configuration. If this emitter follower is removed, then only common base remains there, right? Then the gain of the system will be this V naught of the common base, that divided by Vi, correct? Vi of the common base into Vi by Vs, because the source resistance is there, right? V naught by Vi into Vi by Vs. Vi cancels, therefore the gain will be V naught by Vs. V naught by Vs, right? How we are getting that? V naught by Vi. V naught is the output of common base. Vi is the input of the common base. V naught by Vi into Vi, that is output for this Vs, whatever is there Vs, then input is Vs. So V naught by Vi into Vi by Vs. Emitter follower is not there, but Vi will be the output and input will be Vs. So it is V naught by Vi into Vi by Vs. Right? Now if we use that formula, then we'll get the total gain of the system when the emitter follower is removed. Okay. Now to calculate that, we have to again use the same formula that we have used there. That is, the formula is Vi is equal to Ri by Ri plus Rs into Vs. The formula that we used for calculating part B. Okay. Vi is equal to Ri by, 1 minute. I'll go back to that equation. This equation. Vi is equal to Ri by Ri plus Rs into Vs. Equation 3. We have to use this equation because it's a source voltage is given with source resistance Rs. Vi will be Ri into Vs divided by Ri plus Rs. Note down this equation. Vi is equal to Ri Vs divided by Ri plus Rs. Okay. Now let us write down what will be Vi, what will be Vs, Ri and Rs. What will be Ri here? Ri will be equal to ZICB, ZICB. But what is meant by this? Ri is equal to ZICB. We are considering only common base. Emitter follower is not there. We have removed the emitter follower stage. Okay. So input resistance will be the input impedance of the common base stage. Only common base stage is there. Correct? Then what about Rs? Rs is same. Source resistance will not change. It is same, whatever is given. Okay. Now let us substitute these values in this equation. So what will be Vi then? Vi will be equal to ZICB, Ri is ZICB into Vs. Source voltage is also same, that has not changed. That divided by ZICB plus Rs. Okay. That is, this equation we will get then. Vi will be equal to ZICB into Vs divided by ZICB plus Rs. Vi is equal to ZICB into Vs divided by ZICB plus Rs. This is ZICB is 26 ohm. You have noted down this 26 ohm Zi of common base input impedance. That divided by 26 ohm plus Rs. Source resistance is same, 1 kilo ohm. 1 kilo ohm. Then into Vs, that will be Vi will be equal to 0.025 into Vs. Just verify this portion, 26 divided by 26 plus 1000. You will get 0.025 into Vs. Correct? Now what will be Vi by Vs? Vi by Vs will be equal to 0.025. What about V naught by Vi? V naught by Vi we have already calculated. Where we calculated that? Here, V naught by Vi for the common base stage. V naught by Vi, it is 147.97. 147.97 V naught by Vi for common base stage, right? That we have already calculated V naught by Vi. Use that. We are getting AVS is equal to V naught by Vs, that is AVS is equal to total output voltage by total input voltage. Total output voltage is V naught. Then total input voltage is Vs. So this voltage V naught by Vs, V naught by Vs, this is equal to Vi by Vs, Vi by Vs, whatever we have got here, Vi by Vs into V naught by Vi. Note down this. EVS is equal to V naught by Vs, that is Vi by Vs into V naught by Vi. V naught by Vs is equal to Vi by Vs into V naught by Vi. If Vi cancels, what will remain? V naught by Vs will remain. Yes or no? That is V naught by Vs is Vi by Vs into V naught by Vi. Now substitute the values. Vi by Vs is 0.025 into V naught by Vi is 147.97. 147.97. Okay. The answer will be 3.7. 3.7. So with the gain of the common base stage, when the emitter follower stage is removed, that is nothing but 3.7. Okay. Did you all note down this, students? Have you all noted down the values? I hope example is clear to everyone. This example is clear to everyone. Any doubts in this example? Any doubts in this example? Ankita?
Yes, sir.
Any doubts here?
No, sir.
Okay. Chandrasekhar?
Sir, clear, sir. All clear, sir.
Right. Harshagowda? Harshagowda? Janvi?
Yes, sir.
Ja
Everything is
clear,
clear,
Janvi?
sir.
Okay, fine. Rutik? Chopde?
Yes, sir. No doubt, sir. Clear, sir.
Fine. Sai Prakash?
Yes, sir. No doubt, sir.
Good. Sania?
Yes, sir.
Clear, Sania? Any problem in understanding? Any questions?
No, sir. Understood, sir.
Fine. Shiraj? Shiraj? Mujawar? Shubham? Shubham?
Yes, sir. No doubts.
Good. Suraya Banu?
No doubt, sir.
Fine. Manjunath? Manjunath? Melligeri? Atiya? Atiya? Atiya Developur? Okay. The next class, students, will solve some more numericals, okay, on the Darlington configuration, and then we'll continue with the next topics. Okay, that we will take up in the next class. Any other questions? Any other things you want to ask? Any doubts here? Hope this is clear to you, the concepts and the numerical. Yes. Okay. Then we'll continue in the next class. I'll be taking another 1 or 2 numericals, and then I will continue with the next topics. Okay. Thank you.